This Zoom session is being brought to you by the Fractal Inverse Bullseye Bubble Water. All right, today we're going to be doing section 6.2 and 6.3, and these will be talking about doing arithmetic with rational expressions. A rational expression is a ratio of polynomials, and we'll talk about multiplying them, dividing them, and simplifying them. And then 6.3 we'll talk about adding and subtracting them. And we'll use the usual rules for rational numbers, and we'll add in the whole mechanics of factoring polynomials in order to aid with cancellation. So, for example, if you have a ratio A over B times the ratio C over D, that'll be equal to A times C over B times D. And A over B divided by C over D, we take the reciprocal, D over C, and multiply and get AD over BC. And then we cancel common factors. So, for example, here we'll multiply and divide the same pair of rational expressions. 12x to the 61 over 7x to the 15th times y, 7y over 15 to the 15th times y over 8x to the 27th. Just a second. That'd be sorry. So you multiply across 21x to the 61, y, which equals y to the first. It's always a good idea to put the one polynomial power in that, over 7 times 7y to the 15 times 8x to the 27. All right, now let's see. 7 times 8 is 56, 12 over 56, x to the 61, y to the 1 over x to the 27, y to the 15. Now, then we cancel common factors. 12 and 56 have a common factor of 4. Take 4 from here, you get 3. Divide this by 4 and you get 14. X to the 61 over x to the 27th. We take 61 minus 27 is 34. So x to the 34 in the numerator. And here the denominator has the bigger power. So we subtract that. 51 minus 1 is y to the 14 in the denominator. All right. Now we divide them. 12x to the 61 over 7y to the 15 divided by y over 8x to the 27. We reverse this and put 8x to the 27 over y to the 1 times 12 8x to the 61 over 7x to the 5th. Now when you multiply out, 12 times 8 is 96, 7 is just 7. There are no common factors to cancel. And x to the 61 times x to the 27, you add powers and get x to the 88. X to the 15 times x to the 1st, you add powers and get y to the 16th. So 96x to the 88 over 7y to the 16th. All right, we'll do some examples. We have this is a mess. 3t squared minus t minus 2 over 6t squared minus 5t minus 6 times 4t squared minus 9 over 2t squared plus 5t plus 3 is what? Okay, I skip a large number of steps by the AC method, which we've gone over many times before. And let's see, we get 3t squared minus t minus 2 is 3t plus 2 times t minus 1. 4t squared minus 9 is 2t minus 3 times 2t plus 3. Denominator, 6t squared minus 5t minus 6 factors into 2t minus 3 times 3t plus 2. And this 2t squared plus 5t plus 3 factors into 2t plus 3 times t plus 1. Now, okay, then we cancel common factors. The 3t plus 2 and the 3t plus 2 cancel. This t minus 1 stays. 2t minus 3 cancels this 2t minus 3. This 2t plus 3 cancels this 2t plus 3. All that's left is t minus 1 in the numerator and t plus 1 in the denominator. And so t minus 1 over t plus 1. Now here we have 3n squared plus 5n minus 2 over 12n squared minus 13n plus 3. That divided by the ratio n squared plus 3n plus 2 over 4n squared plus 5n minus 6. Okay, we first, to do this, we first flip this over. Here's its reciprocal. 4n squared plus 5n minus 6 over n squared plus 3n plus 2. Still times the same stuff here. 3n squared plus 5n minus 2 over 2n squared minus 13n plus 3. Now again, we use the AC method to factor this, 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 and this. And we get, for this, 3n squared plus 5n minus 2 factors into 3n minus 1 times n plus 2. 4n squared plus 5n minus 6 factors into 4n minus 3 times n plus 2. This 12n squared minus 13n plus 3 factors into 3n minus 1 times 4n minus 3. And n squared plus 3n plus 2 factors into n plus 2 times n plus 1. Okay, let's see. 3n minus 1's cancel. N plus 2's cancel. 4n minus 3 cancel. We're left with these two factors, n plus 2 over n plus 1. Some more examples. Here we're just multiplying out plain old rational numbers. And let's see, 15 over 24 times 16 over 25. 15, that's 3 times 5. 16 is 2 times 2 times 2 times 2. 24 is 2 times 2 times 2 times 3, 8 times 3. 25 is 5 times 5. Okay, the 3 cancels. This 5 cancels. These 3 2's cancel. We're left with 2 over 5. All right. 12x to the 61 over, oh, did we do this one already? I'm sorry. I'm afraid we probably did. Yes, we did this one already. So, all right. All right, or I'll do it a slightly different way. 12 over 7 times 8. So x to the 61 over minus x to the 27 is x to the 61 minus 27. Y to the first over y to the 15 is y to the 1 minus 15. This reduces the 3/4. This is x to the 34th. Here we'll have a negative power. So y to the negative 14. And okay, negative 14 goes in the power goes into the denominator, x to the 34th in the numerator, 3x to the 34 over 11 over 14, x to the 14, or y to the 14th. This is a cute one. 2y squared minus y minus 3 over x squared minus 1 times x squared plus x minus 2 over 2x squared plus x minus 6. This here factors into 2x minus 3 times x plus 1. This here factors into x plus 2 times x minus 2. This factors into x plus 1 times x minus 1. This factors into 2x minus 3 times x plus 2. All right, then. 2x minus 3's cancel. X plus 1's cancel. X plus 2's cancel. X minus 1's cancel. Everything cancels, leaving, quote, nothing, unquote, behind. But watch out. When you're doing and multiplying and dividing, quote, nothing, unquote, actually means 1. I've often seen people get this wrong and then say 0 because nothing is left. Well, wrong, nothing. When you're adding and subtracting, nothing equals 0. When you're multiplying and dividing, nothing equals 1. So avoid that mistake. Oh, well, and this, did I do this one before as well? Let me see. Oh, I do believe we did do that before. Yes, we did do that before. Well, this one, when you look in the notes, you go through all the details of the AC method. You factor this, then to factor this, then to factor this. That's just the difference of squares. And to factor this. And so we get this. And we get the same factorization we got just above. And after cancellation, we get the same result. T minus 1 over t plus 1. Okay, here. PQ to the 29 over 50 divided by P to the 10th Q to the 38 over 15. Okay, first we'll flip this one upside down. So 15 over P to the 10 Q to the 38. And then we'll write this as P to the first Q to the 29 over 50. Okay, coefficients 15 over 50. And here's P to the 1 minus 10. Here's Q to the 29 minus 38. Now 15 50ths, if you cancel out a common 5, you get 3/10. 1 minus 10 is a 9, P to the negative 9. 29 minus 38 is negative 9, Q to the negative 9. And these negative powers means they're positive powers in the denominator. So 3 over 10 P to the 9, Q to the 9. Now let's see, did I do this one before? 59. Yes, I did.
Yeah, I think it's up there in the beginning, Professor.
Yes, it is. It is. So, okay. Well, I skipped over the steps of turning this into that, this into that, this into that, or this into that, and this into that. But let's, you can review on the notes in Canvas. This is again 3 cases the um, of the AC method. AC method, and this by the PQ method is n+1 times n+2. So I won't go over the details of that. We've been through this before. All right. This one I don't think we did. Did we do this one above?
No, I don't believe so.
All right. This one I will go through all the tedious details. I have to do it at least once. 2x squared 5xy 3y squared over 3x squared minus 5xy plus 2y squared divided by 2x squared plus xy minus 3y squared, 3x squared minus 5xy plus 2y squared. Okay, well, we'll have to flip this over later, but here, this one, 2x squared plus 5xy plus 3y squared. Here, we need two numbers who add to 5 and who multiply to 2 times 3. That'll be 6. 2 and 3 do the job. The sum is 5, the product is 6. So we write 5xy is 2xy plus 3xy. After factoring these two, after factoring these two, and removing a common factor of xy, we get 2x plus 3y times x plus y. This here, 3x squared minus 5xy plus 2y. Here, p plus q must add to -5 and multiply to 3 times 2, which is 6. -3 and -2 work in this case. So write minus 5xy is minus 3xy minus 2xy. Factor these two, common factor of x plus y, minus y comes out, leaving 3x minus 2y. So this goes here, this goes in the numerator. Now here we're going to flip these around, but for now, oh, well, this is too easy. This will be the same thing, so it will cancel. But anyhow, this 2x squared plus xy minus 3y squared, p plus q must equal to 1 times xy. P times q is 2 times -3, which is -6. 3 and -2 do the job. Their sum is 1. Their product's -6. So write this xy as 3xy minus 2xy. Then after some factoring, get x minus y times 2x plus 3y. So, okay, so this is this, 2x plus 3y times x plus y. This is this, 3x minus 2y times x minus y. These we reverse, flipping this to the top, but that'll be this here, 3x minus 2y times x minus y. And this here goes to the bottom, x minus y times 2x plus 3y. Now, right, it should have been obvious here. These were the same, so when we divide them, this goes in the numerator and cancels entirely against that. So in a sense, these were sort of irrelevant. So these and these cancel these. We have a 2x plus 3y. It cancels this 2x plus 3y. And all that's left is this, x plus y over x minus y. Now, here's a relatively simple one. 4r minus 8 over 5r divided by 5r minus 10 over 4r squared. Okay, we multiply this by the reciprocal of this. So well, this is 4 times r minus 2 over 5r. This is 4r squared. This is 5 times r minus 2. Okay, so r minus 2's cancel. R squared cancels against r, leaving a single r in the numerator. And then the coefficients are 4 times 4 over 5 times 5, 16 over 25. That doesn't reduce. So 16r over 25. Now here will be the same two fractions, rational expressions, this time multiplied. So this one becomes 4 times r minus 2 over 5r times this, which is 5 times r minus 2 over 4r squared. Now this time the 5's cancel, the 4's cancel. The r plus minus 2 stay, r minus 2 squared. Your r times r squared is r cubed. And so you get r minus 2 all squared, all divided by r cubed. All right, that's that for that.